So let me get to our lesson. That's not it, I believe. All right, this is it. It's kind of crazy. This one's domain and range. All right, so we're going to start with doing the domain and range, and I'm going to be going back and forth. So I'm going to be doing all the odd ones, and then you're going to do the even ones. So 1 and 3 right here, I'm going to grab my Desmos calculator. So I'm going to go to Desmos. I'm going to do Desmos star test mode. I'm going to grab it. And the first thing I'm going to do is I'm going to type in that trinomial that we have, which is 2x. I'm going to come here, raise it to the second power, plus 8x minus 24. So the only thing we've run at this point was typing it in the calculator. That's it. That's all we're doing. Okay. And then I'm going to look here and I see this is going to be -6 and it's going to be 2. So my domain for the first one here is going to be -6 x and 2. And that's it. Okay, then I got to do my range. So I'm going to go back. I'm going to look at my range. I'm going to see where the bottom is. So I'm going to scroll all the way out. Oh my God, it's all the way down here. Then I'm going to go to the vertex. And I see my very bottom is going to be -32. That's my y value. It's the second one. So I'm going to go back. And I know that my range is going to be all real numbers are greater than -32. And that's it. Okay, those are 2. That's a -6, by the way, and that's 2. Okay, so that's the first one. The second one, we're going to do the same way. Okay, so I'm going to go back to my Desmos calculator. I'm going to type in what we see for 3, not the second one, the 3, which was -2.5 parentheses x plus 1, close the parentheses, and then I'm going to raise it to the second power. Let's see, we didn't know it's a little bit opposite. So we know that my domain, actually, I lied to you guys. I'm sorry. Scratch this. This x value is going to be all real numbers. Because when I did this first one, the x is never in. Same with this one. These things go on, if I keep zooming out, they go on forever. You see, I'm already at 2,000, and it's still going on. So the domain is going to be infinite. Okay, it goes on forever. There's no zeros. So for this one, my domain is also going to be all real numbers. This is just a fancy way of writing all real numbers. Okay, so if you don't want to write all real numbers, like I clearly don't, you can just do R with 2 lines. Okay, now the range is the y values, and we can do our range here. If you look here, it starts at 0. So all y values are going to be less than 0. So it's good to read it out loud to yourself before you write it. So we know that 0 is going to be here. And we know that all y values are going to be less than, so it's going to be facing away from the y, 0. And that's how we do domain and range for those. You type it into Desmos, and that's how you can find the domain and range. All right, so let's move forward. I'm going to go down to question 5 here. And then it says, what is the range of y equals 12 minus x squared when the domain of a set of integers is -2 and 5? Okay, so what I'm going to do is I'm going to type this into my calculator. Okay, I'm going to do 12 minus x squared. So it told us what it was. I mean, it was guessing, but it was like -4 and 4. Let me see. Oh, -3 and 2. That's where it stopped, our range. So we're going to look for -3. Okay. I don't know why I'm getting hung up on this. -3 would be here. Be right there. And then 2 would be right there. So that's if you had a picture that you could do that. We're not going to get hung up on the -3 and -2 part at the end. That's there to confuse you. What only thing you need to know is this part here. It's saying, what is the range? Okay. You don't even need to know the domain because what we can graph is different from the picture that they're given. So we look here and we see that the highest y value in this picture is 12. So we're going to write 12 here. And we know that all y values are going to be less than 12. And that's all we need to do for number 5. It just says what's the range, and that's how we find the range. Okay. The path of toy rocket is graphed below. The height of the rocket, ft, is the function of the number of seconds t the rocket is in the air after launch. What is the domain of the graph of the rocket? So we're just finding the domain. So we have to look at the points. We see we're at 0 here and 4. So our domain is going to be 0. And then we're traveling across the x-axis. We get a little bit bigger, but we're all less than 4. The only thing I'm missing here is that this less than or equal to, because these are solid dots that we are given. Okay, so now we're going to flip over to the back. There's going to be 2 more questions we're going to do the back. It's going to be 9 and 11. Okay. So 9. A rock is thrown in the air. The height of the rock in meters is ht and is determined by this function. What is t? Where is t, the number of seconds elapsed since the trajectory was thrown? What is the inequality that best shows the time in seconds the rock was in the air? Okay, so how long the rock was in the air. If you guys know me, if you've had me for a while, if it has to do with time, anything with time, it's going to be the x-axis. X-axis is always represented by time. Okay, so we have to figure out what the domain is. We're going to be looking for the domain. We're looking for the seconds, which is time. We're going to be finding the domain, which is how long this traveled across the x-axis. Okay, so we're going to type this into Desmos exactly how we see it. I'm going to go to Desmos and I'm going to type that. It's going to be -0.5. Oh, that's the wrong one. My bad. 29.4 plus 24.5 x. We're going to use x instead of t minus 4.9 x squared. Okay, so now we're going to see how long it traveled against the x-axis. One thing that's tricky about this one is that there's no such thing as negative time. Okay, I'm just double checking the numbers. There's no such thing as negative time. So we have to start here. So they were, this is getting a little bit fancy, but they did this on a cliff, and they started from 0 seconds because they're already 29.4 feet off the ground. That's our y-intercept, okay? And then they traveled all the way down to the bottom, okay? So it started from 0 all the way to 6. So that they were in the air. Well, let me actually keep the dots. That's really nice. They were in the air for 6 seconds, okay? Because that's how many seconds they were in the air. So we're going to put 6 seconds. Or you can do the domain. 0 traveled across the x-axis and then stopped at 6 seconds. All right, last one, which is 11. The number of bowling matches that must be scheduled in a league with the N teams is given here, where the team plays every other team only one time. What is the domain of the function of the league is set of the integers 1 to 10, okay? The league is set of integers 1 to 10. What is the range of the function? So we're finding what the range is. So there's no such thing as a half a match. There's a whole match and that's it. You don't play half a match. So what we know that this is going to be discrete data because it's going to be represented by dots because is where each team, every other team only play one time. The domain of the function of the league is set from 1 to 10. And it's only integers. That's another clue that this is discrete. But just know that there's no such thing as a half a match or half a game in real life. I mean, there is sometimes, but not in this scenario. So this is going to be discrete data. Okay, so now we have to graph this. So I'm going to graph this in Desmos. I'm going to grab my calculator. And I'm going to do 1/2 parentheses x squared minus x, close the parentheses. And we're finding the range. So this is going to be all real numbers are greater than 0. And that's what we have. But remember, we only can go up to 10. So I'm going to scroll, scroll, scroll. I don't know if I can get to 10. Won't let me. But I see that 10, yeah, there you go. 10 is 45. Okay. Nine is believed to be 36. 8 is 28. So I'm approximating because this is a pain. 6 is 15. So we're going to know that this is going to be C. Okay. You also don't even have to do this. If you know this is discrete data because it's representing each match, there's only one answer choice that is discrete, and that is C. Okay. The reason why it's important to know that because it's easy to get confused with D, which is not discrete, it's continuous, saying you can play all type of matches. Okay. Now, that is it for my side. I want you guys to do the rest on your own. And then you're going to come bring it with me to check, and I'll give you a stamp if you pass. All right, all by yourself. All right, have a great afternoon and do your best. Thank you. Bye.